Hey, and welcome everyone to this new live stream. So today I am going to explore Qdrant, which is like a vector database, and this will be the first time that I will create a project based on what they have. So let's just like go with that. So basically, Qdrant is a vector database for creating AI application. And if you don't know or if you have heard about vectors before, vectors is like a representation of the data that you are doing, which make it easier for you to do some kind of math stuff on top of it and apply AI algorithm on that. So, for example, that you could go with turning text to vectors and finding the cosine similarity between texts. At that time, you will find the closest text to another one, and stuff like that. So let's just go and check the use cases of Qdrant first. They are going for HR, and so that it can map whatever we have for that. Fee discovery, e-commerce search, which is a cool thing that you might use. Biometric identification, customer support, fashion search, fintech, law. Yeah, this is cool because like here in law, you could just like go and use some kind of like write your case and find the closest case to that case, and then you could just like check that and make some kind of calculation based on it. So here we go, and then I think I could go directly to um let's see what they have for demos. And here for law they have, yeah, so they mentioned this paper in which is like written 2020. Let me see that. It's it's computing similarity between two legal documents. Okay, so this is like a legal information retrieval thing for legal stuff. I think this is cool. I will read that later. So yeah. And here they have this demo for startup search. I think they have kind of, let's see, quadrant here. So they might, let's see, for open source. I think they might search the description of that and might map whatever they are having and showing that. Yeah. So here is that food discovery, e-commerce product, and I would like to check food discovery as well. So my favorite food. Okay, so here we will show you what you like and dislike. Let's say, okay, I don't need that. So I will go and like potato, and then you have everything related to potato. I don't need uh, that. So could I? No, it's not working well. Okay. So I was thinking, okay, so right now it's better. I was thinking that it might show like, let me dislike this. So it's finding whatever I like from the food. I would like to have like, instead of having recommendation results directly, I would like to have a place to see those. Let me see if we have that. Text search, no. Here, find location, no. Here, reset all. Let's reset all and go with. So I would like to see like beside the recommendation results here, it would be great to see the types of food on top of that or somewhere else, so you could just like that and then you see, so you could choose from them, then you could see the results. So I will go with full monty. Let me go for search and chicken. Okay, so it's by text. Okay, this wasn't clear, so maybe we could have this text written somewhere on top. Chicken and let's say salad. Yeah, okay, so they are showing whatever has a chicken and salad on that. So let's just go forward. And yeah, I think this could be done. Could have some kind of, they don't have that um, code for it. But like since it's open source, I think they have the code somewhere on their main organization. Let's just see here. Yeah, here we have that. So I think it would be great to like link this on the project and add a better description of how to use that. So yeah, we will do that later. So I will not get and waste time here right now. So I just go resources, see the documentation. They have the case studies. Oh, they have use studies here, and here they have case studies, articles, blogs. Yeah, I will just go with that. So here in the documentation, they are telling how you could use that, which is like Docker or Python client or spin up a cloud cluster. So we could go with whatever. And here we have the topics that's interesting. Then we have the common use cases. Here we could build a search engine locally with most basic instruction set. And this is just using Qdrant. Then a simple neural search with Aleph alpha. Yeah, Aleph alpha. Recommendation system, search and recommender newspaper article, recommendation system for songs, image comparison system, question and answer. Yeah, so they almost have not all of use cases, but like they have few cases that they are showing here. In the case studies, we could see um, they are writing where has been used. But like I think in case studies, they are missing Twitter, and the last time I think the last product from Twitter they were using Quadrant. It would be great to so just see. I think yeah. So they are using Vector database powered by Quadrant. So I think it would be cool to have Twitter case study as well here, but like that would be depending on their uh, agreement and what they are doing together. Sparse, vectors, Quadrant. Here they have the blog and articles for that. That could be cool to see. And here they have the Medium blog. I think this, yeah. So the last thing they written like in 2022, but like then we have this from Dave Martin. Let's just go back to documentation and see from the beginning. Here they are explaining Quadrant, explaining the vector database and how it works. So instead of like going with OLTP, which is or like OLAP, which is columns and rows, they could just like go with vectors. This is cool. And here, like I remember that I have used something. Yeah, I have used vector similarity to for my search engine, which is like Q.org. If you haven't seen that, it would be interesting to check it. And here we go, which is like a search engine in multi-language for Quran and other stuff. So let's just go here. They are, yeah, they mentioned cosine similarity dot product Euclidean distance, which is like how you find the similarity between the stuff that you are doing or how you calculate whatever you want from that. Here they have the, okay, so let's just go with tutorials directly and see some to do something together for that. So I would like to go with something with just quadrant. So let's just go with semantic search, or they had where it is here recommendation system. So here they have recommendation system and semantic search together. So let's just like go with the simple one, which is semantic search. And to do that, we need to install transformers, use a quadrant client, then have the models that we are using. So they are using a sentence transformer model. And here they are encoding this sentence. So the encoder idea here is translating your, let me just like increase the size of this. So basically it's just like translating your text or sentence to something that would be saved as like numbers. So like some of the system that transformers that we have could be just like translating to the words to the dictionary with the words, and other just like have a different algorithm. So here they are using Allmin LM, and this model is having a 384 dimensional dense. So all the words will be transferred to 384 dimensional thing, which is like the number of elements inside that, and will be based on that. So yeah, let's just go. We need to add the data here. Here they are having the documents, which is what we are having, and define storage location. So we are using the same memory. Okay, we're creating a collection of Qdrant. I And I think the collection here is kind of working like the NoSQL database style. So you create a collection and you add the vectors inside that. But like in NoSQL, you create collection and you add the data. And here we are updating the data, asking the engine questions, and we're getting the response. So let's just like go with here, creating collection with collection name, vector configuration, which is like model vectors based on. So the size will be the embedding dimension that we are getting from the encoder, and the distance will be cosine similarity distance. So we are choosing that. Yeah, so here it's how we measure distance, and the vector size is like to calculate them. Okay. We need to upload the data then. And we will have it on our database after having our collection, which is like, yeah. So here we are going through that description and getting the record and converting it. We are asking the questions here, which is like hits Qdrant search, collection name. So we are choosing the collection. We are choosing the vector that we are going to use, and here we are getting the results. So we could use even like filter the years to choose whatever we want, and then that's it. So I think we could just like at the beginning start by running this, then we could go and do something different. For me, I feel like having um a small UI for this and converting it to, do they have a movie search with the quadrant thing here? I think we could have something like not movie database, movie search quadrant. Yeah, so we have something, one already did that. So they are movie recommender system, which is something cool. And yeah, so they are explaining the results there. So we just like go with what we are having right now, then we will see something else. So this to assume you are in bash shell, use Python documentation to activate virtual environment with commands such as tutorial environment bin activate. Okay. So let's just go with Visual Studio Code. And I would connect to code space. Just wait a few minutes for this to load or whatever they are doing here. Just close all, going to this again, connect to code space. So here we have the open source API, which we used yesterday, and we have something else, or we could use something related to or create something new for us. I will just like, instead of that, I will go and create a new code space. And so I need to choose a repository. Okay. So I will just like go with the one that we used yesterday. I don't need the same stuff that we used yesterday, but I will go with that to just like have a faster experience in developing stuff. So we need to have a recent version of Python, and we need to create a virtual environment first. So let's just like, here we need to wait for opening the remote space, then we could see that. And here they are having the other, they are showing integrations to what? Cohere, Gemini, OpenAI. So you could use Qdrant with OpenAI, and this would be cool. So if you use them together, you might be able to get um, to have a system that will get information from a file and send that file information to OpenAI and save the information here. Then you get like results from that. Yeah, so they are using text embedding, OpenAI embedding create. And yeah, so let's go back to what we are having here, which was the, the search thingy. So let's just go back. I don't need this stuff. I will go to the main file, and here let's just like create a virtual environment. Don't need this one right now. So we need to go with creating virtual environment tutorial env. So this is it. And here we go. So we have the environment. Let's just like run that environment. We are in tutorial environment right now, and we just like could go with this one with the instruction they are having. So we are installing the transformer first. Then we should install the Qdrant client, and we will do the coding related to that. Then they have a full code. Ask engine questions, response, narrow. Don't they have? Yeah, so I think it would be cool if they had a full code written somewhere, so you could just like go and check that instead of getting them from here. And another great thing would be like having it in the Python, was it notebook? Yeah, so if we had it in Jupyter, it would be cool because like at that time you would just run that directly on Jupyter instead of going with the stuff. But just wait right now. I think I have Jupyter, but like I need to check that on my machine, and we could do that later. So right now we are waiting for the collection here. And here we could see that we could just use Jupyter online and have whatever we want. But we'll do that on another stream. So we are waiting right now to install everything here and a new release of beep. Okay, we don't need that, so we could update that as well, but we'll do that later. So we did, let me see, we did the transformer. We need to get the client, and then we could write the code that we want. So while we are waiting for this to just go here, we are having a new bash, and we are making directory, which is Qdrant. And here we could see that we are having Qdrant right now. Then we could just like go to Qdrant and make a file, call it um, search.py. Then we could open that search file. So we could see it here in our, we have the Python extension. Let's just download that as well. And let's just go, we get the client, we are importing the stuff we need from it, which is that client and models. And you are getting the sentence transformer from sentence transformer package using the encoder, which is all mini L6 version 2. This map sentence to, yeah, we talked about that. Let's see if we have something else. Sentence transformer installed. So here they are talking about how to use that background intend use. Okay, we could go right now, and we have datasets here that we could check. Okay, that's cool. So we could see if we have database like um movie dataset. So we have a movie datasets here, and we have the release date, title, overview, January, vote average, vote count. Okay, it's too large, so I will not use that. Then we will need to add the dataset here. So one of the things that I thought about is instead of having datasets in this way, which is like an array of objects in Python, we could just like get a dataset from Hugging Face and use that dataset for our I was wondering like what's the date of this dataset. So we could use that data set instead of having this documents here, but like at that time running the program will take a long. Just set the Qdrant client, get the collection here, which is like naming it and choosing the vector that we are using for that with the dimension and distance that we need. So let's just go with that, upload data to collection. So after creating the collection, we need to add the data from this data here, documents. And why we are doing that, we are just like having records with the information from it and looping over the documents that we want. And we could ask question and we return the response of that question. So right now what we could do is just like have one limit, and then we could just, instead of asking for an invasion, and we could ask for human ambassador at the virus. So we could just ask for um dystopian young boy. So I'm just trying to understand the database that we are having here. So I think we could go and find something related to web. Here we have this, which is talking about hacker doing something related to web here, and we could just like say web hacker. So we could see if we could run that. And here, Python search. Okay, I need to use the virtual environment. So let's just go from here, Qdrant, Python search. And right now we could wait a few minutes to get the results. So my expectation would be having that. Let me increase the size. So I think it's just like right now downloading the stuff. Yeah, so here we have that naming is whatever with hacker and score. So what we could do is hit load. At the end we are getting the score which is like 70%, 0.70, which is 70%. And here we could just like um if you are doing this for production or something like that, you could just um, uh, improve this by like either having I don't think we have Copilot here. Okay, we don't have that. So by either having a formatted printed version of it or like getting whatever you want from it. So if I want just like the name of that not document that movie, I could just like write name, get that, and here I could multiply this by 100, so I will get the 100% of it and percentage of that. So we could just like have it something like this. I didn't save that, but like fine. So we could have just like a direct result. Uh, so dictionary has no attribute name. Payload. So let's just say, just remove this to double check. We have the name here, but it's not showing. And yeah, so let me just go with Copilot. Hey, Copilot, chat. I think I will need to, not sure about that, but like I might need to log in. Here we have Copilot. Do we have it? Okay, so it's enabled. Yeah, okay. So let's just say print the name only, the book on underscore. So we could see, but like this is dictionary, so we already have the name. I'm not sure why didn't they get that. And copyright is not being helpful right now. Okay, so we should use the other definition for that, I think, which would work. How are we going with JavaScript definition? So yeah, so here we have that neuromancer score, whatever it is, and here let's just say I would need to parse that. So I haven't used Python for a while, or as you can see, I didn't use it for a very long time. How to get only the integer of a number. So here instead of hit score whatever, so we need to just get yeah, so we need to get that to int, and we could get just like um wait, that integer number instead of having all of this extra information that we don't need. So here we have that. So We are going Neuromancer score 70%, which is a better like result of what we are getting. And if you are using, as I mentioned, as a backend or a backend stuff, so you could just like give this results from whatever you are having, and you could turn this upload records to um, an endpoint that is getting the information. So you will add it to your database. So let's just move forward and see what else we could do with this. So here we are just searching a collection of, I think it's books. Yeah, books. I thought it's movies. So we could just like get some kind of mm, books data set and try to perform different um, results on that and see how stuff would go. Or we could, um, let's see, Nuller search service. Or we could just like go and check what they are having here. So yeah, so this is what I was talking about, which is like turning data sets to vectors. So they are having that in the second tutorial. And this vectors is being turned to uploaded to Qdrant. And then you could use the search API from Qdrant and deliver that to through backend or something like that as an API. And here they are using fast API. And here you will need to transform your raw data and then create search function, manipulate it first. You will need to download and prepare. Okay, so this is similar to the principle that I mentioned at the beginning of, like, at the end of the last tutorial, which is having as, um, and I think that here they are talking about their startup search engine. Yeah, so here they are having it in fast API. And at the end of that semantic search, I am wondering if the semantic search stuff would make sense if you are using Arabic language because it will be harder to find um, like datasets and models that has been tried in that language. But yeah, so here let's just go and see what they are doing from the beginning. They are getting sample data from Google API and startups demo data. I think, let me see if that will be opened. So I think it's just like, okay, I can't see that. Uh, some that has been added there. Then we are getting sentence transformer and relevant packages, which is similar to what we did in the previous tutorial. And here they are using a encoder, which is like the previous one, and they used a GPU for device, uh, getting the data, then turning those data to, yeah, so after that they are turning to those data into vectors and getting the shape of that vector and saving that to file named startup vectors, running Qdrant in Docker. Then they uploaded that data to Qdrant directly. And created a collection called startups, had the vector params as size for 384, which is the size of our vector here. Another way they could do that is a dynamic way when whatever you are having. So you could just like add the site that you want from there. And I'm not sure if they could. Let's just go and create collection Qdrant. I'm not sure if in Qdrant if you. So here we have the collections. Let's just see if we could create collection Qdrant. Okay, so you could use that in core or whatever. And here we could see that we are setting the configuration with size distance model. Hmm. Could we increase the size? They didn't mention anything here related to size, so I'm not sure about that. So let's just go here. So here they used recreate instead of create directly because this way they might remove the old one in case if you are trying that multiple times. Okay, and here they are talking about how we could get that 384 in a dynamical way. Let's just go and see what we are having. They open the file, get the payload, uploaded it to, and then they loaded the vectors. Then we upload that data to our like collection, and then we should build a search engine API, search API for that. We are just I define that. We write the search function, which getting text string, which is the search that we are and want, and they are converting that to um, a vector, which is similar to the first. Just go here. Here, when we are doing this kind of search, where it is, we are encoding that search to a vector. So this is the same logic here, getting the result, which is like, yeah, so it's similar to this one. Instead of having that as like in one line, they made it in two lines. Then they got the payloads, which is the results, and added it to the end of this API. And here we have filters, and you could have our own different filters for that if you wanted. So just go, and then we could deploy that search with Fast API. So in Fast API, we will get that app, get our neural searcher, add that like get stuff, and write it in Python, which is like just the result based on the text that we are getting from the search, which is making stuff easy here because like they implemented the search in another like class, which is the neural uh, searcher class. Then we could just like find the results and print it into API. That's cool. So this is the same like idea that I mentioned when I saw this, which is like you could turn it into an API and use that. And they already have an example out of it here in the second tutorial, which is something cool. So let's see what they have in guides. So here they are talking about administration, how we could look stuff, installation optimizes, telemetry monitoring, configuration, troubleshooting, and examples. I think we could just like have a fast overview of what we did today. We did just like going through the documentation of Quadrant, and you saw with us how you could read from your documentation and how that would help you to write your stuff and understand it with basic information. And then here we implemented the first tutorial. We went through the second tutorial, which is like using an API for that. So instead of just like having this tutorial, you could just like you could have another if you are using fast API. So maybe you could have an API to parse another text, to provide text always and whatever it is. So it depends on what you need to do, and then we could improve that based on your needs. And yeah, so that's it in general. Quadrant is, let's go back. So it's a vector database that's using vectors and enabling everything related to vectors for development, which is something really cool to have that as an open source project and have it as an extra service that you could use, because otherwise you might need to implement everything related to vectors by yourself and use different logics for that, which could be consuming, time consuming, and even willpower consuming for you. So yeah, if you enjoyed this, I hope to see you in another stream in the future, and I hope you to enjoy your time and night or whatever it is. And don't forget to check the search engine that I built before, which is like built on top of a pure JavaScript without having any libraries. So it would be a great experience for you to understand how stuff would go. And if you don't know anything about vectors and how that would work, I would just suggest you to do some quick or some study related to that. If you don't know any resources, just let me know and we will work on that together. And thank you for that and have a great time. Bye bye.